Hello, everyone. My name is Elena Bisinicu. I'm from the National Institute for Marine Research and Development, Grigore, Antipa, Constanța, Romania. I am a scientific researcher. I am also a Black Sea Young Ambassador working on marine ecosystem and environmental assessment in the Black Sea. During this lecture, I'll guide you through Module 1, which focuses on harmonizing methodologies and data to assess and mitigate the effect of multi-stressors. In this session, we will define multi-stressor, why do they matter, discuss how harmonization improves data reliability and supports ecosystem-based management, and we will review practical examples from intercalibration exercises and joint monitoring activities in the Black Sea region. What are multi-stressors? Multi-stressors refer to multiple environmental pressures which are acting simultaneously on marine ecosystems. These pressures can interact, sometimes can amplify, other times can reduce each other's effects. Such examples include climate change, eutrophication, pollution, overfishing, and habitat modification. Understanding their combined impact effect helps us design more effective management and conservation measures. Here you can see a visual example illustrating how multiple stressors interact within the marine ecosystem. This image helps us better understand the overlapping pressures that are affecting the Black Sea environment. The Black Sea is facing multiple pressures, starting from eutrophication, pollution, overfishing, and climate change, all acting together as multi-stressors. Effective management of these complex challenges require comparable, high-quality data across all member states. Harmonization ensures that monitoring results are consistent, reliable, and interoperable, meaning that data from different countries and from different laboratories can be directly compared and further combined. This approach supports ecosystem-based management and allows for adaptive responses to emerging environmental change. The visual highlights the key goals of the harmonized approach: understanding the multi-stressor interaction, integrating the biological and the social economic data, learning from data from existing harmonization data and initiatives, and applying best practice in order to support that evidence-based policy and management actions. Together, all these elements form the foundation for effective and cooperative environmental governance in the Black Sea region. This slide summarizes the main goal of the harmonization process, which is to standardize and validate the method across the Black Sea region and to ensure the data comparability. Step 1 is standardized sample, which is followed by validating methods at pilot sites for regional adoptions. Step 3 applies some principles, meaning that data should be findable, accessible, interoperable, and reusable, and align with European Science Cloud standards. Finally, step 4 ensures comparability, allowing data from different countries and disciplines to be integrated into shared regional assessment. These 4 steps define the pathway toward harmonized monitoring and responsible data sharing in the Black Sea area. Here are the 5 key steps in the harmonization process. We start with step 1, which is the inventory of current practices. Help us understand how each partner currently performs monitoring and analysis. Step 2 is the development of standard operation procedures in order to ensure that all partners follow comparable methods and quality standards. Step 3 focuses on intercalibration, where laboratory results are compared and verified for consistency. At step 4, we validate at pilot sites, testing the methods under the real environmental condition. And finally, step 5, which provides recommendation aligned with the BSE map and the Black Sea Commission, ensuring harmonized methods support regional monitoring programs. Altogether, these steps form the methodological backbone of the harmonization framework for the Black Sea. The harmonization works focuses on key domains that reflect both living components but environmental pressures in the Black Sea too. The biology domains include plankton, benthos, seagrass, and macroalgae, which are essential indicators of ecosystem health. Marine litter focuses on microplastic in water, sediment, and biota, highlighting the interaction between the pollution and the organisms. Chemistry examines nutrients, dissolved gases, heavy metals, and organic compounds in order to assess the water quality and to find out where the pollution sources are. Finally, the genetic applies the environmental DNA and the metagenomics in seawater and sediment to detect biodiversity and ecosystem change. Together, all these domains ensure a comprehensive approach to monitoring the Black Sea environment. This is the full harmonization workflow, which starts from sample collection and goes to regional data sharing. It begins with sampling, where teams collect field samples from multiple sites and laboratories using standardized protocols. The next step is intercalibration, which is a comparative analysis among labs to ensure the analytical consistency. Then comes the external quality control, which represents the Q&A audit through several initiatives, such as APAM or quasi-MEM. Following the data, validation involves reviewing, correction, and approving results for accuracy. Finally, the shared results represent the harmonized data set that will support regional assessment and collaboration across the Black Sea states. Several intercalibration exercises have been conducted in order to align laboratory practices and data interpretation. This includes chemistry intercalibration under quasi-MEME, macrozooplangton's Q&A audits, and the cruise intercomparison in the Bosphorus area. Together, this initiative ensures consistent and high-quality results across all Black Sea partners. The chemistry intercalibration exercises. This exercise tested key parameters such as nutrients, chlorophyll, trace metals, and organic carbon. Samples were analyzed through the quasi-MEME reference laboratory to ensure international comparability. Results showed improved analytical precision, identified calibration weakness, and strengthened the collaboration among the regional laboratories. The macrozooplankton intercalibration exercise it was organized using the own sample module. This process improved taxonomic harmonization and addressed identification challenges across the regional laboratories. As a result, data comparability for benthic communities across the Black Sea was significantly enhanced. Finally, the joint cruise, which was conducted in July 2024, compared in situ measurements and sensors aboard two research vessels. The focus was on consistency across the instruments and protocols during a shared transect in the Bosphorus area. This collaboration helped validate monitoring approaches and strengthen the trust between regional scientific teams. The key benefits. Harmonization provides multiple benefits. Improved data reliability and long-term comparability, stronger regional cooperation, and better assessment for cumulative impacts. These benefits enhance the overall effectiveness of marine monitoring and management efforts. The key message is towards a sustainable and resilient Black Sea. To conclude, the harmonized monitoring and data management are essential for addressing the combined effects of multi-stressors on the Black Sea ecosystem. Through collaboration and shared methodologies, we can build a sustainable and a resilient future for the Black Sea region, which will be grounded in science and cooperation. Thank you for following this module. You can find additional reading material, datasets, and related resources on the lecture page for deeper exploration of today's topics. I appreciate your attention, and I hope that this session has provided valuable insight into the harmonization of methodologies and data in the Black Sea region.